Thank you so much for everybody that attended today. My intent today is to really bring to your attention this is sort of fairly new to the arena of cybersecurity and deep learning. It's another branch of artificial intelligence, and my upfront statement to everybody is I'm not a data scientist, I'm not a software engineer by trade or anything. So the bits and bytes that go into making these things is not something that is my area. What is my area, though, is that I've worked with dozens and dozens of technologies over the years, and my knowledge has always been hands-on. It's always been my preference because coming from a business background originally has helped me a lot in being able to work with board members and executive teams to really translate what is a very complex subject into language that is more understood from a business perspective. And one of the things I've always been doing is to find technologies that will actually help to minimize the amount of management required for dealing with very complex issues around cybersecurity. And so I've had hands-on in a lot of different things. So this is me. I started in the mid-90s actually in IT. I soon developed an interest in security because it just seemed like a bit of an anomaly in terms of what was happening in IT. And a lot of the things that were happening at the time seemed really neat and kind of different. And so I pursued that as a career choice. And I've never really looked back because I've been very lucky in a lot of the projects that I've done around the world and helping really big organizations with massive security challenges. I'm a security architect as well as a network architect. I've also always been hands-on with everything I've done. I've managed teams, but I've also worked alongside those teams as well, just out of a pure personal interest in understanding how all these things work. In the last few years, I've really focused more on the governance side of the house, because that's as equally important as it is to understand about technologies as well, because those two have to go hand in hand if you want to build a successful security practice in your organization, or if you're a consultant who wants to be able to provide really good value for your customers. And so these are all of the areas that I've actually worked in. The interesting thing is when you work for small companies, you can't afford to hire everybody, so you have to be everybody. But it's always worked out really well for me. I always like to start my presentations by giving you a couple of my influences, because when I started out in this business, there wasn't really much in the way of materials that you could read about cybersecurity. There wasn't a lot of things that were developed. There was no such thing as building governance around security at the time, or having compliance type frameworks, like PCI or HIPAA or ISO 27001 or any of these things they really weren't around at that time. So trying to find influences and information about this was a bit of a challenge. And so it was almost like a wild frontier at the time. So really, like the two areas that I found a lot of influence in was I'd read Sun Tzu, The Art of War, and it occurred to me that a lot of the things that he talked about in there were very kind of helpful in terms of trying to understand how you approach cybersecurity business. It's no secret that we use a lot of military acronyms and slangs and stuff related to what they do in our industry, because there's a lot of similarities between the two. And so I've always approached this business on a philosophical perspective. Kevin Mitnick was also a really major influence to me, because previous to my having read his first book, I always thought that the hacking was just purely a technical endeavor. And that's how I learned. I built a lab, and I did a lot of testing and of different tools to see, to kind of brush up on my skills in hacking, which we obviously use for part of the business that we did for white hat hacking in terms of pen testing that we did back then. But the thing that I learned about from Kevin was that in his first book, he barely used any technical skills to actually defeat people and get what he was looking for. He just basically pick up the phone, pretend to be somebody based on some analysis that he did of an organization, and he would get away with pretty much anything, including being able to listen in on the FBI when they were chasing him and listening in on their phone calls to find out what they were doing. And there was lots of other things. And so I learned the aspect of social engineering back then, and it's still prevalent today. Anybody clicking on a link has obviously been duped into doing so. And so the social engineering thing was always strong, but much stronger today. So the topic today, as I mentioned, I'm not a data scientist, but the technologies that we're looking forward to seeing in the future are going to be much like the firewalls or next generation firewalls that we were introduced to years ago. And whereas we learn enough about these things to be able to make them effective in organizations. So this is where deep learning actually sits in the AI family. Lots of people would be familiar with the machine learning evolution from artificial intelligence, because machine learning is used a lot in today's world for lots of different things. But deep learning is sort of is a more relatively new compared with the rest of that. But its introduction into the cybersecurity world is long overdue and much appreciated. I say lots of things to people. I have lots and lots of phrases and sayings that I've picked up over the years, but really what this comes down to in today's world is that you literally could spend millions in technology, but you'll always be defeated by the end user with one click. Because one of the things that organizations don't understand, for instance, if I download malware from my Gmail account, that link that I use to connect to Gmail is encrypted right down to the desktop. So if your antivirus is not working, or it's turned off, or it's not updated, or a user clicks on a link, that's literally all it takes to defeat all of that technology. And that's why we're reading so much about companies that are struggling today and are being hit with ransomware. I'm currently involved in about 3 different projects to try and help companies clean up after ransomware attacks. And it's always the same thing over and over. End users are clicking on links that they're not supposed to, and this is the aftermath of what happens. In order to kind of put some context around the deep learning for the use case that I'm talking about today, I thought it was important to kind of bring you up to speed on really what's happening globally, to show you, and then when we start talking about deep learning, you can learn to understand how this is relevant to that. So the Ponemon Institute, on a yearly basis, along with IBM, actually do this study to try to understand how much does a data breach cost. And so what they do is they have a big sampling of lots and lots of different industries that they go to, and they do what they call an activity cost analysis, which means that when somebody has a breach, they go in and actually interview everybody that's involved in recovering from that breach. Say it's a ransomware attack, as an example. Everybody that's involved in that, is it lawyers, and is it the media people, all of the IT people, the management, right up to the board, and they calculate the costs of each one of those individuals, and then they work out an average based on the company, and then they work out an average across the different industries as well. And so the average cost of a data breach is $3.92 million as of last year, and some of them are obviously really huge. Some of them are a lot smaller, but that tends to be what the average is. And the cost per lost record is around about $150 a record. And so there are tools actually that you can run across your environment, and it will tell you how much sensitive data that you have in the environment. If you times it by that number of 150, it would tell you basically how much it would cost you if you were to get a breach and you were to lose all that data. One of the interesting things that they also discovered too as well is, and this is an ongoing statistic, is it takes 279 days to contain a breach. It's about 200 days to actually detect the breach in the first place, which is about average. But even those numbers are our best efforts. 200 days is like the best number possible, because a lot of these organizations are more than a year before they actually detect something that's in their environment. And a lot of the times it's not even them that's detecting it. It's usually some third party outside that's saying, hey, your network is trying to kill me. And so they find this out from other people. So this is the statistics, as I mentioned before. You can see that the numbers are going up, and they've been up and down a little bit in terms of the days to contain a breach. So it's always in and around the 200-day mark, and then there's some amount of days to actually contain that. So once it's detected, it's all the work that's involved in actually trying to clean that up and contain it. So this is sort of the global average is what you're seeing here for these things. This is just a statistic in terms of what a piece of data is worth by industry. Healthcare is by far the biggest target. it has the most amount of data, the most amount of useful data that where cyber criminals can make money on the dark net. And when they post this stuff, and this is on average what they would possibly get as well for each piece of data. In terms of the arenas or vectors that are responsible for these breaches, there is a certain amount of human error in there. But malicious or criminal attacks are actually on the rise and account for more than 50% of breaches. There is lots of money to be made by cyber criminals in the theft of all kinds of data. And because they realize this, and also they realize that targets are pretty soft today, there's not a lot of, especially here in Canada where I'm based, there's not a lot of structure around how people look, to really take care of their sort of cybersecurity practice. Typically don't have plans, and they don't really have a strategy to really secure their environments, and there's a reason why they're getting breached all the time. And the cyber criminals know this in particular. You can see from here that the prevalence of cyber criminals is going up and up all the time. As I mentioned before, the increase of criminal attacks is on the rise because they know that most organizations are pretty soft targets, and they can pretty much steal data at will because it's just so much easier to do that. Just bounce across this one here. So this is where we kind of lead into more where the initial topic comes from, actually. And I'm talking about endpoint security in particular, just because, and again, it's my personal opinion based on all of the research that I've done and things that I've seen for myself. The endpoint typically seems to be the weakest link in the whole cybersecurity strategy. One of the things I noticed from years ago, probably about 10 years ago, is that I noticed lots and lots of malware being downloaded onto workstations and not being detected and stopped by the antivirus agents that are sitting on these machines, even though they may have been completely up to date. It just didn't seem to make sense. When you're involved in so many things, these are sort of fleeting thoughts that you have and not really put a lot of thought into them or a lot of research into them, because to you, the antivirus really should be working, and there shouldn't be really any debate about it. But it's in the last few years I started to really look at it seriously and started to really realize that endpoint security, the way it is from a signature base that it has been traditionally, it's just not working. And we see this over and over and over again. Companies are being hit all the time. And when you think about this, if a company has ransomware and they have firewalls and antivirus, why are they still getting hit? But this is a big overriding question that keeps coming up over and over and over again. Every one of these organizations have some kind of firewall and they have some kind of antivirus, but they're still getting hit. And as part of my research, what I learned to understand was back into even as far back as 2014 and beyond, really, Symantec actually came out and said that typical signature-based virus detection is pretty much dead as a security option. And so these are the people that originally were Norton, who invented the concept of an antivirus agent and started building signatures to combat viruses back in the day. And they pretty much are saying now that it's dead as a capability, and it's well publicized as such. And once I read that, it started to make sense to me, because I just couldn't really understand why is it people are getting hit with this. If you look at the way signature-based virus detection works, it takes a human being to first see the virus, dissect the virus, and then create a signature for it in order to be able to detect it the next time, which is no good for the people who get hit with the virus and either takes down their operations or in some cases actually puts them out of business. That's a very common statistic in itself. And so the antivirus thing is a problem, and an even bigger problem is that we're actually relying on the end user to actually be the people that are going to help defend as a last gasp effort against malware that's actually very prevalent. And they're the last people that we should be really relying on for that. What they really need help is in providing proper tools that can detect these things and stop them in their tracks. And so that's where the advent of the deep learning comes in. Just to sort of bolster the information that we discovered in terms of doing research on antivirus, one of the things that we, even as far back as 2012 in Perva, a big security organization, had worked with the Technion Institute Israeli Institute of Technology. And what they did was they had collected 80 malware samples, some new, some old, and ran them through sort of the traditional, well-known antivirus engines that are out there to try to understand what the detection rates were for these things. And in some cases, like the detection rates were pretty poor, but it took weeks for their antivirus to be updated to even detect that particular malware. So that in itself is not really a good thing. But the irony is that consumers and enterprises are spending a third of the purchases of security technologies and software and everything is literally going on antivirus, and it obviously does not work. So something really has to change, and obviously something is very broken. This is just a quick graphic to kind of show you the what the outcomes were from these things. So anything in red was where it was not detected actually by these different antivirus vendors. And so this is just really a sampling. There are dozens and dozens and dozens of different antivirus solutions out there. I always remember people keep asking me all the time, Ken, which one do you think is the best? And back then I didn't really know what to say, because really and truly they were all, the same at varying degrees, because one day Trend Micro might pick up on something that Symantec didn't, but the next day Symantec would pick up on something that Trend Micro didn't. And so they sort of varied across time, across these different ones. So it was really a 50-50 choice between, which antivirus vendor you really want to go with, because in terms of performance, it was pretty much the same thing. SMEs and SMBs, this is a major statistic that came out a couple of years ago that I saw. It was 60% of hacked SMEs and SMBs go out of business 6 months after a major attack. And it's really easy to understand how this happens, because you're talking about very few people with no security skills or knowledge. They don't have the right tools in place to defend against and literally their livelihood is dependent on them being operational on a day-to-day basis. They might have, significant contracts with major corporations, as I've seen a lot over the years. And these corporations are not tolerant of small organizations that are not capable of either staying in production to manage their responsibilities, or the loss of maybe that big corporation's data that typically is in the contract. You lose that data, you lose the contract, and so these small businesses go out of business because they have no way to recover from that. And a lot of this is, as I mentioned before, if you're getting ransomware or even any other malware that takes down your operation, this is a really big deal for these smaller organizations. Again, this is something from the Quantum Institute. A couple things that I read from here, and I had read previously in earlier years, was that zero-day attacks are becoming more prevalent, and there's a good reason for that. Zero-day and fileless attacks, compared to known or existing attacks, are more likely to compromise an organization. Fileless attacks are on the increase, because they can live in memory for months and months and months. You'll find this a very common thing with servers that are running, 100, 200, 300 days without being rebooted, because they have to have 24/7 availability. So being able to reboot these servers on a regular basis is not something that many organizations that are providing vital services are able to do. And so the hackers know this, and they create malware that will live in memory, and they literally could be there for months and months before rebooting. And even after rebooting, because they live in the registry, they then get reloaded back into memory once the machine comes up. And so when you see statistics like, the average time for detection is 200 days, you can almost equate that to how long a server is typically up and running for before it's rebooted. So the deep learning as far as endpoint security, that's something I'm actually working on right now to introduce into our customer base in order to try to provide them with a lot more robust solutions, more so than what they have currently. With deep learning as an endpoint solution, it doesn't need any new user interaction or learn to create new detection methods. Deep learning, the way it operates, is it's basically a neural network brain. And it learns the same way that humans learn. And what it learns what it will learn ultimately is what does a piece of malware actually look like, or what does a properly constructed file look like. Anything anomalous to that would be a flag for it, and it would be able to detect that as malware and actually shut it down. there's no signatures at all. One of the big problems with signature-based antivirus as well is that you have to have a massive library of signatures. This impacts performance on systems when they're doing virus scanning, because it has to load the entire library in order for it to do its checking. Whereas not the case with deep learning. It's a single agent, goes on the endpoint, and it actually works autonomously to look for bad malware that might end up on your system. It actually can detect zero-day malware. Lots of people say that they can detect zero-day malware. Part of the problem with zero-day detection is that with machine learning, for instance, it's trained to be able to look for very specific patterns within malware. If it sees something that it thinks might be malware, but it's not quite sure, the likelihood is still going to flag it as malware, and it ends up in the junk folder, and some analyst has to go in there and actually verify whether or not this thing is really malware. This is not great for if you're running an enterprise or you have very slim resources for security, which is typically what's happening out there. To pull analysts away to spend time trying to determine whether a file is actually a piece of malware, almost second guessing what the machine's telling them, that's a colossal use of somebody's time, which they're not being used for more strategic reasons, which is really a vital aspect of what companies need today. These tend to be a cloud-based solution, so there's really no infrastructure for an organization to have to invest in any of that aspect of it. And if you want to look this up, what they do is they use GPUs to actually train the brain. And deep learning is actually used for lots of different cases. It's just in our case, we're using it in the cybersecurity field. Just to put some context around the deep learning has actually been around since 2010. But its application in the world, something that you would be familiar with, is the driverless vehicles are actually using deep learning. So with the driverless vehicle, it needs to be able to make decisions based on things that it's seeing. It needs to be able to make decisions based on things that it's learned to understand previously, but might have some kind of obscurity or some kind of noise interference that is obscuring its ability to be able to see what it had been taught originally. So it has to be able to make decisions based on all kinds of different variables, too many to really think about from a human perspective. Like, there's millions of different things that can happen on the road particularly when you're driving long distances. And so for a car to be able to make decisions on its own, it needs to have a neural network type brain to be able to know, well, I haven't seen this particular issue before, but I do understand that it's a problem and I need to do something about it. One of the examples of that would be, let's say, a car coming up to a stop sign. Machine learning, or in the case of an antivirus signature with a signature wire, it would say, okay, you see a stop sign and it looks like this, you need to stop at the sign. But what if the car's driving along the road and it sees the stop sign up ahead, but it's covered in branches? A signature writer, in our world today, we have to wait till the car has an accident, and then we're going to write a signature to say, oh, sorry, by the way, if you happen to see a stop sign with these branches in front of it, you need to stop. Obviously, this doesn't work, and it cannot work. And in our world, what we're really challenged with is the fact that malware and all kinds of other exploitable ways of compromising systems and organizations is really done in an automated fashion. It's done on a more industrialized basis. So we need an industrialized response to be able to deal with these things. I came across this actually because I thought it was relevant to the discussion for today. This was the first ever driverless vehicle. It's the first ever autonomous vehicle. It was built by Stanford University in 1961, and it was capable of actually making decisions every 10 to 15 minutes to make a move that would only drive it 1 meter in distance. And so that was a magnanimous achievement for 1961. But really, in today's world, this is pretty much what we're stuck with, right? Is that, we have to wait till malware appears. It has to create problems before it becomes seen, and then somebody writes a piece of code to defend against it. So we're almost going backwards in terms of the way we're dealing with endpoint as a problem. again, just to put this into context, artificial intelligence was around since 1950. The concept of that really is a high level. It's just, can a computer do things that a human normally would do? And so antivirus, the way signatures are working, it's almost, you could say it was artificial intelligence to some degree, because it's actually performing a function that a human might have done at some point. And then we introduction of machine learning back in the 1980s. But nowadays, what we really need in the cybersecurity world is something that actually will help and work for us on a much bigger scale, and much faster ways of dealing with things. So with the neural network that they build for these things, they keep saying is that it's basically you're building a brain, and what you're doing is you're feeding it with millions and millions of samples of whatever it is that you're actually you want to train it on. It could be for medical use, it could be driverless vehicles, it could be any number of different things that you might want to use as a use case. In our world, it's the cyber security challenges that we have, and so in order to create these endpoint solutions, basically feeding the brain millions and millions of samples of what malware looks like, and it's learning to understand how these things are constructed, and for it to be able to detect the changes. We talked about fileless malware and how its application in ransomware is going to be a huge benefit to us. We've done a lot of testing even in our own labs to see how it compares with traditional antivirus, and it's pretty impressive in a way that it can pick up and detect 100% of new malware, even though it's never been seen before in the wild. In order to really help to kind of further understand how deep learning is distinguished between the other types of solutions that we have in the marketplace, one of the things that deep learning needs to be able to do, as an example, is to be able to tell the difference between, like in this example, a cat and a dog. The dog and the cat, if I was describing what a dog looked like and a cat looked like in these scenarios here, we'd be saying, it's got pointy ears, a pug nose, and big eyes, and a fairly rounded head. But really, what you're describing could be either one of those two things. Now, as a human, we'd look at that and go, oh yeah, I know that's a cat, and I know that's a dog. The typical machine learning or signature-based, it's not able to make those distinctions. But deep learning, because it's learned to understand the way a human does, it learns to understand the differences between these because of the sampling that it has. Is enough for it to be able to make an independent determination by itself, and so is able to make these distinctions. And so in our world, again, being able to tell good from bad is really, really important. When you introduce variations into there, like we do with malware, there's tens of thousands or even more new pieces of malware that comes out every day. Being able to detect these things is just not possible for a human to be able to make those distinctions. You need a machine to be able to make those distinctions and make decisions on there. So in sort of a signature-based scenario, for instance, we say, this dog has 2 ears and the cat has 2 ears, et cetera, et cetera. But the minute your malware puts on a top hat or sunglasses, now all of a sudden the game's changed and your detection rate has dropped to 0. And so again, that's one of the reasons why we need this new advancement in the technologies to be able to help us. Another use case that I started working with recently, actually, ever since I put this presentation together, this was something that came to my attention since we launched the idea of this particular talk for today, was another use case that's really sorely needed in our industry, where one of the problems with, if you look at somebody that gets malware on their system, especially with these new triple threat type malware that's out there, you've got the malware that will elevate its privileges, and then it downloads more tools to be able to steal your data. And then eventually what it's going to do is going to encrypt your data. And that's at a high level, it's called a triple threat. And that's something that's very, very prevalent today, because these malware writers, what they learn to understand is that not everybody pays the ransom, and so they don't make any money. But if they can steal your data before they encrypt your data, then they're at least guaranteed that they can sell what they've been able to acquire on the dark web and make some money, irrespective of whether you pay the ransom or not. But beyond what happens to malware when it ends up in your workstation is, it's designed to go and steal this data. And a lot of the reasons why they get away with it is because organizations really don't know where their data is. And that's a fact, because they will tell you that it's on this server, in this corner, in this room, in this network somewhere. But the reality is that users tend to download this data a lot of time onto their laptop so they can take it with them to work at home or work in, a coffee shop or something like that. What ends up happening is they get malware on there and they lose that data. And so this is where some of the risk is for an organization, is really trying to understand not only where the data is, but being able to classify the data to let the organization know that, we have 20% of the data that we have is, super secret sensitive stuff. And then we've got a certain amount of data that's really public knowledge and we don't care if it gets out there. This classification is something that's almost would be impossible to do, because organizations have, tens, hundreds, thousands, millions of records and stuff that they keep in their organizations. So to retroactively go and try to, label all of these documents individually by hand would need an army of people, and it would take them forever. And every new piece of data that was created, they would have to be able to stay on top of that as well. It's an impossible task, but it presents massive risk for the organization because this data is everywhere. So you can see it's almost like the evolution of how somebody is able to compromise your system. They download a bunch of tools which allows them to spread and make their way around the network, and they're just stealing data as they go along because they're the ones doing the searching. They figure out what the databases are and learn to understand potentially also where your sensitive data is, because they're in your network for months and months and months, doing a lot of reconnaissance. So the ability to be able to identify all of the critical information that an organization has, and to then retroactively stamp each document to say, this document is sensitive, is hugely important. It's going to be hugely important for organizations, because this ties into data leak prevention. The only way data leak prevention can work is if it understands, when it looks at a file, does it have the prerequisite stamp in there that tells me that this is a sensitive file and it shouldn't leave my organization. This has always been a struggle for, especially in anything I've ever been involved in when we're doing data leak prevention. For somebody to put the word confidential in the file is not really very helpful, because there are millions of files on the internet that have the word confidential in it. And when a data leak prevention technology sees that, it flags it as being a company document, when in fact it's not. So there's lots and lots and lots of false positives, as there are with signature-based antivirus. Hence the reason why we're absolutely in need of deep learning as a technology that will actually come in and help us in lots of different ways and lots of different use cases. So my talk will end with this. The benefits really to business is we really want to be able to create a driverless experience for analytics. There are so few security people generally around the world. I think the number is going to be something in the order of about 3 million unfilled positions in the next few years. That is a significant amount of gaps in terms of what we have for available resources. And so even if we had the right amount of people that were out there, really what we need these people doing is to be working more strategically. They need to be working for organizations in a way that's going to help to benefit the organizations, not just for today, but for years to come. To strategize around what they should be doing, what kind of structure they should be building from a cybersecurity perspective to help to protect organizations. But really what I find a lot of the time, and I know it to be true in a lot of organizations, is that there either aren't any security people, and it's always falling on IT, or the security people that do exist are basically constantly fighting fires. And they're fighting fires because they don't have any strategy around how to actually defend the organization properly. And so this is a massive gap, not just in the available resources, but for the ones that are around tend to be doing a lot more work than they should be doing, because there's really no strategy around what they should be doing. And I think things like deep learning and its advent into our world and the use cases that are still to come are going to be hugely helpful in being able to free up a lot of the time that these analysts are spending currently just in doing a lot of manual labor. So I talked about, having analysts be more strategic in terms of tactical. They have a lot of capabilities. There's a lot of things that they learn. It's a very specialized field. It's a completely different thinking methodology than it is for typical information technology. operations. It's a very different mentality altogether. And so the specialty nature of that really should be used for more, for more strategic purposes. Deep learning, used correctly with the advent of it on an endpoint solution is, in my opinion, is definitely going to save businesses from going out of business, because that's really the weak point in any organization, regardless of how many resources you have and how much money you spent on technologies and how much you spent on actually building your strategic, strategic house, basically, in terms of how you manage security. We really need the help of technologies like this. And it ultimately will replace signature-based detection systems. I talked about endpoint security today, but the problem still exists in things like intrusion detection and intrusion prevention technologies as well, because they are signature-based. They can only prevent if it's seen something before and the signature's been written for it. So that's the reason why you're seeing malware just making its way through all of these, very expensive and very capable firewalls, is because they're not able to see the signature, in a lot of cases, like the zero-day malware that comes through. But if something is encrypted, as I mentioned earlier, from Gmail or OneDrive or Dropbox or something like that, there's no way for these technologies typically to be able to see that. There are technologies, obviously, that we've implemented man-in-the-middle type technologies that are doing SSL decryption. They do inspection and then re-encrypt traffic, fully aware that these things exist. But again, if they've not seen that particular malware before, they can decrypt, inspect and re-encrypt. But if they've not seen it before, they're going to let it through. So again, this is still a weak point in what we have for technologies today. And one of the biggest things really is to be able to track behavior across a wider area of anomalies. It's not possible for a human to remember that, this weird thing happened 2 months ago and keeps coming up every now and again in a different guise. So especially when criminals are doing reconnaissance on your networks, a lot of times that stuff is really not detected. It's not really seen as being anything malicious. I can foresee a situation where deep learning is going to be able to track those types of behaviors and keep track of where they're coming from, the types of behavior that they do, and anything that's, of a severity that takes place. It's going to be able to pull all that information together in a much faster way than we typically do with humans. And so that is the cavalry, I believe, that we've been waiting for a long time. So I hope this has been useful in learning to understand what deep learning is doing for us in the cyber world. And that's my presentation.